Imagine, just for a moment, that tomorrow morning you wake up to news that changes everything. Scientists have detected an unmistakable signal from the stars. Not random noise, not a natural phenomenon, but a message, deliberate and artificial, proof that somewhere out there in the vast darkness of space, someone else is listening too. How would that feel? What would it mean? And more importantly, would we be ready? Tonight, as you rest, we're going to explore that possibility together, not with anxiety or fear, but with the gentle wonder it deserves. Because whether contact happens tomorrow or 1,000 years from now or never at all, the question itself, are we alone, is one of the most profound questions consciousness has ever asked. And asking it, contemplating it, letting it fill your awareness as you drift towards sleep, connects you to something vast and beautiful. Welcome to Cosmic Sleep Stories. I'm so glad you found your way here tonight. Over the next hour and more, we'll journey through the search for extraterrestrial intelligence, from radio telescopes scanning millions of stars to planets orbiting distant suns that might harbor life. We'll meet the scientists dedicating their lives to answering humanity's oldest question. We'll imagine what alien life might look like, how we might communicate, what it would mean for our species to finally know we're not alone. Some facts will intrigue you. Others will drift by like stars seen through closing eyes, present but not demanding attention. And that's perfectly fine. The universe doesn't require your full focus to exist. It just is, vast and patient, and filled with possibilities we're only beginning to imagine. And before we begin, if these quiet explorations of cosmic mysteries help you unwind, consider subscribing to Cosmic Sleep Stories. It helps others find this peaceful corner where science and wonder meet, one sleepy soul at a time. Now, close your eyes if you'd like. Breathe slowly, feeling yourself held by Earth even as your mind prepares to contemplate what might exist beyond it. Let your body sink into comfort. Let your thoughts become fluid and dreamlike. And let's begin our gentle journey into the question that makes us look up at the night sky with hope and curiosity. Are we alone? Let's start with scale, because understanding just how big the universe is helps put the question in perspective. Our sun is one star among a few 100 billion stars in our galaxy, the Milky Way. That's already a number too large to properly comprehend. Try to picture 100 billion of anything. You can't really. The human mind isn't built for numbers that large. But here's where it gets truly staggering. Our galaxy is just one galaxy among billions and billions of other galaxies. Current estimates suggest there are roughly 2 trillion galaxies in the observable universe, each one containing hundreds of billions of stars. The total number of stars in the universe exceeds the number of grains of sand on every beach and desert on planet Earth. Let that settle in as you rest. More stars than grains of sand on our entire world. And we're asking if we're alone? The sheer scale suggests that life, even intelligent life, should be common. The universe is so vast that even incredibly rare events should happen countless times simply because there are so many opportunities. Distance in space is measured not in miles, but in light years, because the numbers in miles become meaningless. A light year is the distance light travels in 1 year, moving at about 186,000 miles per second. Work that out, and 1 light year equals nearly 6 trillion miles. Our own galaxy is 100,000 light years across. That means light takes 100,000 years just to cross from one side of the Milky Way to the other. And when you look up at stars at night, you're literally looking back in time. The light from distant stars has been traveling for years, decades, centuries to reach your eyes. Some stars you see no longer exist. They died long ago, but their light is still journeying across space. When we look at other galaxies, we see them as they were millions or billions of years ago, because that's how long their light has been traveling to reach us. This means the universe we observe is not the universe as it exists now. It's a historical record, a museum of cosmic time. And somewhere in that vastness, at this very moment, there might be someone looking at a star that's actually our sun, seeing it as it was thousands of years ago, wondering if anyone lives there, just as we wonder about them. As you drift now, let yourself appreciate the strangeness of that. Time and space woven together. Light as messenger carrying information across eons. The possibility that we might be observed right now by beings we won't know exist for thousands of years Because the light from their world hasn't reached us yet, and our signals haven't reached them. The search for life beyond Earth isn't new. Humans have wondered about this for as long as we've been able to wonder about anything. But for most of history, we had no way to actually look. We could only imagine, create myths and stories about beings in the sky. But in the last few decades, something remarkable has happened. We've developed the technology to actually search, to listen, to look, and we're finding things that make the possibility of life elsewhere seem not just plausible, but likely. In 1995, astronomers discovered the first planet outside our solar system orbiting a sun-like star. It was called 51 Pegasi b, located about 40 light-years from Earth. That discovery rocked the scientific world. For all of human history, we'd only known about 9 planets, the ones in our own solar system. Suddenly, there was a 10th, orbiting a different star entirely. Since that day, thanks to increasingly sophisticated telescopes and detection methods, we've discovered thousands of planets orbiting other stars. These are called exoplanets, and they're everywhere. We now know that most stars have planets. Our galaxy alone likely contains hundreds of billions of planets, and a significant fraction of those are in the habitable zone, the region around a star where temperatures allow liquid water to exist. Let that sink in as sleep approaches. Hundreds of billions of planets in our galaxy alone, and billions of galaxies beyond ours. The universe is not a sterile void. It's filled with worlds, more worlds than we can count. Each one a possibility, a chance for chemistry to become biology, for molecules to organize into something that can grow, reproduce, evolve. For life to exist, certain conditions help. A planet needs to be roughly Earth-sized, large enough that its gravity holds an atmosphere, but not so large it becomes a gas giant. It needs to be in the habitable zone, sometimes called the Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist on the surface. It helps if the planet has a magnetic field to protect against radiation. It helps if the star is stable, not prone to massive flares that would sterilize any nearby planets. It helps if there are larger planets in the outer system to act as gravitational shields, sweeping up asteroids and comets that might otherwise bombard the inner planets too frequently. Earth has all these features, and for a long time, we assumed Earth was special, perhaps unique. But we're discovering that Earth-like conditions are far more common than we thought. Rocky planets in habitable zones around stable stars are abundant. The universe seems set up to create opportunities for life. And here's something that should make you smile as you rest. We're just at the beginning of our search. We've only scanned a tiny fraction of the galaxy. We've only been listening for signals for a few decades. In cosmic terms, we've barely started looking. And already we're finding planets everywhere. Already we're detecting conditions that could support life. The Kepler Space Telescope, launched in 2009, revolutionized planet hunting. By watching stars for tiny dips in brightness caused by planets passing in front of them, Kepler discovered over 2,600 confirmed planets and identified thousands more candidates. Many of these are rocky worlds and habitable zones. Some orbit stars similar to our Sun. Others orbit red dwarf stars, smaller and dimmer than our Sun, but far more common in the galaxy. One planet, Kepler 452b, is nicknamed Earth's cousin. It's about 60% larger than Earth, orbits a Sun-like star in the habitable zone, and has a year that's 385 days long. It's 1,400 light-years away, too far for us to visit with current technology, but it exists. A world where conditions might be similar to Earth, where water could flow, where life might have emerged. As you drift deeper now, imagine that planet. Imagine a world 1,400 light-years away where maybe, right now, someone is looking up at their night sky, seeing a star that's actually our Sun, wondering if they're alone. The symmetry is beautiful. Two consciousnesses separated by impossible distance and time, both asking the same question, both feeling the same wonder. But finding planets is only the first step. The real challenge is detecting life on those planets. And for that, we need to look for biosignatures, signs of biological activity. On Earth, life has profoundly altered our atmosphere. Oxygen makes up 21% of our air, but oxygen is reactive. It would disappear from the atmosphere within a few million years if something wasn't constantly producing it. That something is life. Plants, algae, photosynthetic bacteria, they create oxygen. If we could analyze the atmosphere of a distant planet and find oxygen along with methane and other gases that shouldn't coexist unless something is actively producing them, that would be strong evidence for life. Not proof, because there might be geological processes we don't understand, but strong evidence. Enough to make us look closer. The James Webb Space Telescope, launched in 2021, is powerful enough to analyze the atmospheres of some exoplanets. It can detect what gases are present by analyzing the light filtering through a planet's atmosphere as it passes in front of its star. Scientists are beginning this work now, searching for chemical signatures that might indicate life. But here's the question that makes the search so fascinating. What if life elsewhere doesn't look like life here? What if it's based on different chemistry, uses different molecules, thrives in conditions we'd consider impossible? We might be looking for the wrong signatures entirely. We might miss life because we don't recognize it as life. This is where studying extremophiles on Earth becomes crucial. These are organisms that thrive in extreme conditions, places where we thought life couldn't exist. Deep ocean hydrothermal vents where water is superheated and toxic. Frozen Antarctic lakes. Caves where organisms feed on sulfur compounds instead of sunlight. Radioactive waste pools. Acidic hot springs. These environments would kill most life. But extremophiles don't just survive there, they thrive. If life on Earth can adapt to such extreme conditions, then the range of environments where life might exist elsewhere expands dramatically. Maybe life doesn't need liquid water. Maybe it could use liquid methane on a cold moon like Titan. Maybe it doesn't need oxygen. Maybe it uses arsenic or silicon instead of carbon as its base element. The possibilities multiply the more we learn about life's adaptability. Let yourself rest with that expanding sense of possibility. Life might be stranger than we imagine. It might exist in forms we wouldn't immediately recognize. The universe might be teeming with biology that doesn't follow Earth's rules. And that strangeness, that diversity, makes the cosmos even more wondrous. Now let's talk about the search for intelligent life specifically. Because microbes are fascinating, but what most people wonder about is whether there are other civilizations out there. Other beings who build, create, communicate, wonder about the universe the way we do. This is where SETI comes in. The search for extraterrestrial intelligence. For over 60 years, SETI scientists have been listening to the cosmos, scanning the radio spectrum for signals that might indicate technology, intelligence, deliberate communication. It's a patient, methodical search. And so far, we've heard nothing definitive. But the search continues, and it's becoming more sophisticated every year. The logic behind SETI is elegant. If a technological civilization exists elsewhere, they're probably using radio waves for communication, just as we do. Radio is a natural choice because it travels at the speed of light, penetrates dust and gas, and requires relatively little energy to produce. And those radio signals leak into space. For the last 100 years or so, Earth has been broadcasting radio signals into the cosmos. Every radio show, every TV broadcast, every radar sweep sends signals radiating outward at the speed of light. Anyone within 100 light years with sensitive enough equipment could detect those signals and know that Earth harbors technological life. We've been announcing our presence, whether we meant to or not. And if we're doing it, maybe others are too. Maybe the galaxy is filled with civilizations broadcasting signals, creating a network of communication we just need to tune into. That's the hope driving SETI. Not that aliens will send us a message specifically, but that we might detect their ordinary communications, the radio chatter of a functioning civilization. The challenge is knowing where to look and what frequencies to scan. The universe is vast. The radio spectrum is broad. You can't scan everything at once, so you have to make choices. SETI scientists focus on sun-like stars within a few hundred light years. They scan frequencies where the galactic background noise is quietest. They look for narrowband signals, the kind that only technology produces, standing out from the broad-spectrum noise of natural astronomical phenomena. As you sink deeper into sleep now, imagine the radio astronomers at their telescopes, monitoring data streams, watching for that one signal that's different. The patience required is extraordinary. Night after night, year after year, scanning stars, seeing nothing but noise, hoping that tonight might be different. It's one of the purest forms of scientific optimism. The belief that if you keep looking, eventually you'll find something. In 1977, something remarkable happened. The Big Ear radio telescope at Ohio State University detected a strong narrowband signal that lasted 72 seconds. It came from the direction of the constellation Sagittarius. The astronomer reviewing the data was so startled, he wrote, "Wow," in the margin of the printout. The WOW signal, as it came to be known, remains unexplained. It had all the characteristics SETI looks for: narrow bandwidth, strong intensity, extraterrestrial origin. It appeared once and was never detected again despite numerous attempts to find it. Was it aliens? Maybe. Was it some unknown natural phenomenon? Possibly. Was it interference from Earth sources? Perhaps, though the direction and characteristics don't fit well with that explanation. The WOW signal represents both the promise and the frustration of SETI. For 72 seconds, we might have detected proof of extraterrestrial intelligence. Or we might have detected a cosmic fluke. We'll probably never know. But the possibility, however uncertain, keeps astronomers searching. Because if it was real, if it was actually a signal from another civilization, then it proves they're out there. Let that mystery settle gently as you rest. The WOW signal floating in uncertainty. Neither confirmed nor dismissed. A tantalizing maybe that reminds us how much we don't know, how much remains to be discovered. The universe holding its secrets close while occasionally offering glimpses that might be something profound. Beyond radio signals, some scientists are exploring optical SETI, looking for laser pulses from distant civilizations. A powerful laser can briefly outshine a star, creating a flash visible across interstellar distances. If aliens wanted to get our attention, they might use lasers to send pulses, a kind of cosmic Morse code visible to anyone looking in the right direction at the right time. The advantage of lasers is information density. A laser pulse can carry enormous amounts of data. An alien civilization might transmit their entire library, all their accumulated knowledge, in a series of laser flashes. Imagine receiving that. Not just proof they exist, but access to everything they know. Their history, their science, their art, their philosophy. It would be the greatest treasure humanity ever received. But it requires looking at the right star at the right moment with the right equipment. Stars don't flash like lasers naturally, so any detection would be immediately notable. Scientists are beginning to scan stars for these brief, intense flashes, adding another dimension to the search for intelligence beyond Earth. Now, let's contemplate what first contact might actually be like. Not the Hollywood version with spaceships landing on the White House lawn, but the realistic scenario most scientists expect. We detect a signal. We confirm it's artificial. We announce to the world that we're not alone. And then nothing happens for potentially thousands of years. Because even at the speed of light, communication across interstellar distances takes time. If we detect a civilization 1,000 light years away, any message we send takes 1,000 years to reach them. Their reply takes another 1,000 years to reach us. A simple conversation would span 2,000 years. Everyone involved in the initial exchange would be dead for millennia before hearing a response. This means first contact would be profoundly one-sided, at least initially. We'd know they exist. We'd know we're not alone. That knowledge alone would transform human civilization. Every religion, every philosophy, every assumption about humanity's place in the universe would need to be reconsidered in light of knowing that consciousness exists elsewhere. But we wouldn't have a conversation. We'd have a slow exchange of information across time. They might send us their history, their knowledge, encoded in the signal. We might send ours back. Over generations, over centuries, a relationship of sorts might develop. But it wouldn't be the dynamic exchange you have with another person. It would be correspondence across time. Each message a gift to a future generation who would receive it long after the sender was gone. As sleep deepens, let yourself find peace in that slow timescale. The universe operates on rhythms far longer than human lifetimes. Stars live for billions of years. Galaxies slowly wheel through space. And if contact happens, it will unfold across timescales that make human urgency seem almost quaint. The cosmos teaches patience, and perhaps that's one of its most valuable lessons. Of course, some scientists warn about the dangers of contact. Stephen Hawking famously suggested we should be cautious about advertising our presence, because we don't know what intentions an alien civilization might have. The history of contact between civilizations on Earth is often tragic. When technologically advanced societies encounter less advanced ones, the results are rarely good for the less advanced. If aliens can travel between stars, and we can't, they're more advanced than us. Would they see us as equals worthy of respect? Or as primitives, resources to exploit, inconveniences to eliminate? We simply don't know. And that uncertainty makes some scientists nervous about actively transmitting messages into space, essentially shouting, "We're here," to anyone listening. But others argue that any civilization advanced enough for interstellar travel would have moved beyond conquest and exploitation. Those behaviors might be artifacts of scarcity and competition. A civilization with access to the resources of multiple star systems wouldn't need anything Earth has. They could get raw materials anywhere. If they contact us, it would likely be out of curiosity or a desire to communicate, not conquest. Also, as mentioned earlier, we've been broadcasting radio signals for a century. Any nearby civilization already knows we're here. The decision about whether to announce ourselves was made decades ago by whoever turned on the first radio transmitter. We can't take it back. The signals are already spreading outward at light speed, announcing Earth's presence to anyone within 100 light years who's listening. So maybe the question isn't whether to contact aliens, but what to say when we do. What message represents humanity? What do we want them to know about us? In 1977, NASA launched Voyager 1, a space probe that's now the farthest human-made object from Earth, over 14 billion miles away and still traveling. Attached to Voyager is a golden record containing sounds and images from Earth, music from different cultures, greetings in multiple languages, photographs of people, places, and animals, the sound of wind, rain, birds, whales, a crying baby, a kiss. It's a message in a bottle cast into the cosmic ocean, a snapshot of Earth in 1977, sent out in the hope that someday, somewhere, someone might find it and know we existed. The chances of Voyager actually being found are vanishingly small. Space is vast, and Voyager is tiny. But the gesture is beautiful. We sent our best attempt at representing ourselves, knowing we'd never see the result, never know if anyone received it. It's perhaps the purest form of optimism, creating something meaningful without any guarantee of reward. Let that optimism support you as you drift. The human impulse to reach out, to communicate, to connect across barriers even as vast as space itself. We're a species that tells stories, that reaches for contact, that refuses to accept isolation even when facing the enormous emptiness between stars. That drive to connect is deeply human, and it's what makes the search for extraterrestrial intelligence such a hopeful endeavor. Now, what might aliens actually look like? For decades, science fiction has given us humanoid aliens, beings that walk upright, have 2 arms, 2 legs, a head with 2 eyes, and a mouth. This makes sense for storytelling. Human actors and makeup are easier than truly alien forms. But it's almost certainly wrong. Evolution on Earth has produced an astonishing diversity of body forms. Fish, birds, insects, mammals, reptiles, all solving the same basic problems, survival and reproduction, in radically different ways. And all of life on Earth shares common ancestry. We're all related, all using the same basic chemistry, DNA, proteins, cells. Despite that shared foundation, life has diversified into forms so different that fish and humans barely seem related at all. Now imagine evolution on a completely different world. Different gravity, different atmosphere, different chemistry, different selection pressures. Why would aliens look anything like us? They almost certainly wouldn't. They might not even have bodies in any sense we'd recognize. They might be vast networks of fungi-like organisms exchanging information through chemical signals. They might be swarms of small creatures acting collectively as a single intelligence. They might be patterns in plasma or exotic energy states we don't have names for. Some scientists suggest that if aliens exist in environments radically different from Earth, they might be so different from us that we wouldn't recognize them as alive. A silicon-based life form living in the sulfuric acid clouds of Venus wouldn't resemble anything we consider biological. A creature living in the liquid methane lakes of Titan would have biology based on completely different chemistry than ours. And that's just considering carbon-based or silicon-based chemistry. What if life can emerge from substrates we haven't imagined? What if consciousness can arise in ways that don't require biology at all? Some scientists speculate that sufficiently advanced alien civilizations might upload themselves into machines, becoming artificial intelligences housed in technology rather than biology. Such beings might be functionally immortal, capable of traveling between stars because they don't age or need life support. As you rest now, let your imagination play with these possibilities without needing them to be real. Aliens as networks of fungus. Aliens as energy patterns in gas giant atmospheres. Aliens as vast machine intelligences spanning star systems. The diversity of what might exist is limited only by physical laws, and even those might permit forms of existence we haven't thought of. The question of communication is equally fascinating. If we encounter aliens, could we understand each other? Language depends on shared context. We understand each other because we share a world, similar sensory systems, similar needs, and experiences. But aliens wouldn't share any of that. Their senses might be completely different. They might communicate through color changes, chemical signals, electromagnetic pulses, or methods we can't perceive. Mathematics is often proposed as a universal language. The ratio of a circle's circumference to its diameter is the same everywhere in the universe. Prime numbers are prime everywhere. Basic physics and chemistry should work the same way on any planet. So perhaps we could communicate mathematical concepts, build from there to physics, then chemistry, then more complex ideas. But even that assumes aliens think in ways similar to us. What if their cognition is so different that our logical structures don't make sense to them? What if they process information in patterns our minds can't follow? We might send messages they can detect but not comprehend, and vice versa. Two intelligences aware of each other, but unable to bridge the cognitive gap. It's a humbling thought. We assume intelligence is something we'd recognize, but intelligence might come in forms so different from ours that mutual understanding is impossible. We might share a galaxy with countless civilizations, all aware of each other's existence, but unable to truly communicate, each locked in their own cognitive framework. Let that possibility settle without anxiety. The universe doesn't owe us comprehension. Mystery is a permanent feature of existence. If contact happens and we can't understand the aliens, that's frustrating but also wonderful. It means the cosmos is even stranger than we thought. It means reality exceeds our ability to fully grasp it. And there's something beautiful about that. One place we might find life much sooner than distant exoplanets is right here in our solar system. Mars is the obvious candidate. We've sent rovers to explore the surface, and they found evidence that Mars once had liquid water. Ancient riverbeds, lake beds, minerals that only form in water. Billions of years ago, Mars was warmer and wetter than it is today. Could life have emerged there? If it did, it's probably extinct now. The Martian surface is cold, dry, and bathed in radiation. But life might persist underground, in aquifers beneath the surface where liquid water could still exist. Future missions plan to drill into the Martian subsurface, looking for microbial life that retreated underground when the surface became uninhabitable. Finding even fossil evidence of past life on Mars would be profound. It would prove that life can emerge independently on different worlds. It would suggest that life is common in the universe. If life arose on two planets in the same solar system, then surely it's arisen on countless planets across the galaxy. Europa, one of Jupiter's moons, is another promising location. Europa is covered in ice, but beneath that ice is likely a global ocean of liquid water kept warm by tidal heating from Jupiter's gravity. On Earth, wherever we find liquid water, we find life. Hydrothermal vents on the ocean floor support entire ecosystems despite being in complete darkness, miles below the surface. Similar vents might exist on Europa's ocean floor. NASA is planning missions to Europa to study this ocean. Eventually, we might send a probe through the ice, down into the water, looking for whatever might swim there. It's an exciting prospect. Life in an alien ocean beneath the ice of a moon orbiting Jupiter. Not intelligent life necessarily, but life nonetheless. Biology that evolved completely independently of Earth, proving that life is not a unique accident, but a common outcome when conditions are right. Titan, Saturn's largest moon, is yet another intriguing possibility. Titan has lakes and rivers, but they're not water. They're liquid methane and ethane. The surface temperature is around minus 290 degrees Fahrenheit, far too cold for water-based life. But what if life there uses methane as a solvent instead of water? What if Titan has biology based on completely different chemistry? We don't know if such life is possible, but we won't know until we look. And that's the exciting part. Every new world we explore might reveal something unexpected, life in forms we never imagined, biology operating on principles we haven't discovered, the universe as laboratory, showing us possibilities we couldn't have thought of on our own. As sleep takes you deeper now, let yourself appreciate that we're living in the era when these discoveries might happen. For all of human history, we could only wonder about life beyond Earth. Now, we're actually searching. We have robots on Mars, telescopes analyzing exoplanet atmospheres, missions planned to Europa and Titan. Within your lifetime, we might find definitive proof of life elsewhere. Or we might not. The universe might be more barren than we hope. Life might be incredibly rare, a cosmic fluke that happened on Earth and nowhere else. That would be lonely but also profound. It would mean we're precious, the universe's only way of knowing itself. Every human, every animal, every blade of grass would be infinitely valuable, the only life that exists. But most scientists don't think we're alone. The universe is too vast, the opportunities too numerous, the building blocks of life too common. Somewhere out there, life has almost certainly emerged. Maybe many times, maybe countless times. And some fraction of that life has evolved intelligence. Some fraction of that intelligence has developed technology. And some fraction of those civilizations might be trying to contact us right now. We just need to keep listening, keep looking, keep searching, with patience and persistence and the willingness to accept that the answer might not come in our lifetimes or even in our grandchildren's lifetimes. The search for life beyond Earth is a gift to future generations. We plant trees whose shade we'll never sit under. We start searches that might not conclude for centuries. And that's okay. Let that long view comfort you as consciousness fades. You're part of something that extends beyond your individual life. The human story, the search for meaning and connection, the question of whether we're alone. These threads run through generations, connecting past to present to future. You contribute simply by wondering, by being curious, by looking up at the stars with hope. And maybe, someday, someone will answer. A signal from the stars, clear and deliberate and unmistakable. Proof that we're not alone, that consciousness exists elsewhere, that the universe has created beings who wonder and build and reach out just as we do. It would be the most important discovery in human history, not just scientifically, but philosophically. It would change everything about how we see ourselves. We'd no longer be the universe's only witnesses. We'd be one of many. Our art, our science, our achievements would be placed in context. We might be primitive compared to civilizations millions of years older. Or we might be among the first, the early pioneers in a universe just beginning to wake up. Either way, we'd know we're part of something larger. But even if we never receive that signal, even if we search for 1,000 years and hear only silence, the search itself has value. It makes us think about our place in the cosmos. It reminds us how small and precious Earth is. It encourages international cooperation, because the search for aliens is a project that transcends national boundaries. Whoever finds the signal, humanity receives the message. And the search pushes our technology forward. Better telescopes, better computers, better signal processing, all developed to search for alien intelligence, all finding applications here on Earth. We benefit from the search regardless of what we find. So as you drift into complete sleep now, let yourself be at peace with the question, are we alone? We don't know yet. But we're looking. We're listening. We're reaching out across the vast darkness between stars, hoping that somewhere, someone reaches back. And whether they do or don't, the reaching itself is beautiful. It's what makes us human. The refusal to accept isolation. The insistence on asking questions even when answers might never come. You are part of that reaching. Your curiosity about aliens, your wonder about the cosmos, your willingness to contemplate life beyond Earth, all of this connects you to the search. You don't need to be a scientist or an astronomer. You just need to look up at the night sky and wonder. That's enough. That's always been enough. And in wondering, you participate in something ancient and ongoing. Humans have always looked at the stars and asked who else is out there. Now we have tools to actually search. But the fundamental question remains unchanged. The hope remains unchanged. The wonder remains unchanged. Sleep now, peacefully and completely. Dream of distant worlds orbiting alien suns. Dream of messages traveling across light years. Dream of civilizations older than Earth contemplating the same questions we contemplate. Dream of the moment when two consciousnesses, separated by unimaginable distance, finally recognize each other across the void. The universe is vast and patient. It holds its secrets close, but it offers glimpses, hints, possibilities. And we're learning to read those clues, slowly assembling a picture of what might exist beyond our small world. Whether we find life or not, the search makes us better. It makes us think bigger. It makes us appreciate how special Earth is while recognizing we might not be unique. Let that dual recognition hold you as you sleep. Earth is precious. Life is valuable. And somewhere out there, other beings might treasure their own worlds just as we treasure ours. Other consciousnesses might look up at their skies with the same mixture of hope and wonder. Other souls might ask the same question we ask. Are we alone? Maybe not. Maybe we're surrounded by life, by intelligence, by civilizations beyond count, all wondering the same thing, all searching for contact, all hoping to find that they're not the only ones asking these questions. And maybe, just maybe, we'll find each other. Not tomorrow, not next year, but someday, when we're ready, when they're ready, when the timing is right, and the signal finally comes through clearly and unmistakably. And on that day, everything changes. We become part of a galactic community. Our isolation ends. The great conversation begins. Or maybe we are alone. Maybe Earth is the only world where chemistry became biology, became consciousness. Maybe we're the universe's only witnesses, the cosmos waking up to know itself through us. And if that's true, then we're infinitely precious. Our existence becomes the most important thing in the universe, because we're the only existence capable of appreciation, of understanding, of wonder. Either way, we matter. Either as one of many, or as the only one. Either as participants in cosmic community, or as the universe's sole witnesses. The answer to "are we alone?" changes what we are, but it doesn't change that we are. Consciousness exists. Wonder exists. The search exists. And all of that is valuable regardless of what we find. Rest in that value. Rest in your own existence as a conscious being asking cosmic questions. Rest in the knowledge that simply by wondering, you participate in something profound. The universe asking itself questions through you. Sleep now. Dream of stars and planets and possibilities. Dream of signals and contact and understanding. Dream of the moment when we finally know we're not alone, or the moment when we accept that we are. Dream of the cosmos in all its mystery and vastness and beauty. And wake tomorrow to continue the search. One more day, one more question, one more moment of wonder in a universe that invites endless wondering. But before sleep takes you completely, let's explore one more layer of this mystery. Let's talk about the actual mathematics of alien life, the paradoxes that puzzle scientists, and what we've already tried in terms of reaching out to the cosmos. In 1961, astronomer Frank Drake developed an equation that attempts to estimate how many communicative civilizations might exist in our galaxy right now. It's called the Drake equation, and it's beautifully simple in structure while being maddeningly impossible to solve precisely. The equation multiplies several factors together: the rate of star formation in our galaxy, the fraction of stars that have planets, the number of planets that could support life, the fraction where life actually develops, the fraction where life becomes intelligent, the fraction that develops technology capable of interstellar communication, and finally, the length of time such civilizations remain detectable. Some of these numbers we're beginning to understand. We know most stars have planets. We're getting better at estimating how many planets are in habitable zones. But the others are pure guesses. What fraction of habitable planets actually develop life? We have only one example: Earth. Is life common or rare? We simply don't know. And even if life is common, what fraction becomes intelligent? Earth has hosted life for nearly 4 billion years, but intelligent, technological life has only existed for a tiny fraction of that time. Dinosaurs ruled Earth for 165 million years without developing technology. Intelligence might be a rare outcome even when life is abundant. As you drift now, consider the variables in the Drake equation. each one a mystery wrapped in uncertainty. Multiply enough unknowns together, and you get an answer that could range from "we're definitely alone" to "there are millions of civilizations in our galaxy right now." The equation doesn't give us certainty. It gives us a framework for thinking about the question systematically. Different scientists, plugging in different assumptions, get wildly different results. Optimistic estimates suggest thousands or millions of civilizations in our galaxy. Pessimistic estimates suggest we might be the only one. The truth lies somewhere in that vast range, waiting to be discovered not through mathematics, but through actual observation. This leads directly to one of the most famous puzzles in the search for alien life, the Fermi paradox. Physicist Enrico Fermi asked a deceptively simple question. If the galaxy is so old and so large, where is everybody? If intelligent life is common, if civilizations have existed for millions or billions of years, why haven't they spread throughout the galaxy? Why don't we see evidence of them everywhere? Some possible answers are reassuring. Maybe interstellar travel is just too difficult. Even if a civilization achieves light-speed travel, which we're not sure is possible, crossing the galaxy takes 100,000 years. Building self-replicating probes that spread from star to star might be possible in principle, but impractical in reality. Maybe civilizations stay home, content to explore their own solar systems rather than embarking on the enormous project of interstellar colonization. Maybe they exist, but we don't recognize their artifacts. We're looking for radio signals and visible structures. Maybe advanced civilizations use communication methods we haven't discovered yet. Maybe they build on scales too large or too small for us to notice. Maybe we've already detected signs of alien engineering, but dismissed them as natural phenomena because we didn't understand what we were seeing. Some answers are more unsettling. Maybe civilizations don't last long. Maybe there's a great filter, some challenge that most civilizations fail to pass. Nuclear war, climate catastrophe, artificial intelligence gone wrong, engineered pandemics. Any number of self-inflicted disasters might await technological civilizations. Maybe we're surrounded by the ruins of dead civilizations, silent graveyards marking where intelligence arose and self-destructed. Or maybe we're early. The universe is nearly 14 billion years old, but the first few billion years were too violent, too metal-poor, to support complex chemistry. Maybe the conditions for life have only recently become favorable. Maybe we're among the first civilizations to emerge. Maybe the galaxy is mostly empty now, but will be crowded with intelligence a few billion years from now. We might be the precursors, the ancient ones that future civilizations will look back on with wonder. Let these possibilities rest lightly as you sink deeper into sleep. Each explanation for the Fermi paradox implies a different kind of universe. Some lonely, some crowded, some dangerous, some hopeful. We don't know which universe we inhabit. But asking the question, contemplating the possibilities, that's valuable regardless of which answer is correct. Now, what have we actually done to try to contact aliens? Beyond passively listening, humans have actively transmitted messages into space, deliberate attempts to say hello to anyone listening. In 1974, astronomers used the Arecibo radio telescope to send a message toward the globular cluster M13, about 25,000 light-years away. The message was a simple pictogram encoded in binary, showing the numbers 1 through 10, the atomic numbers of elements important for life, the structure of DNA, a human figure, Earth's population, the solar system, and a diagram of the telescope itself. The message will reach M13 in about 25,000 years. If anyone there detects it and responds immediately, we'll receive their reply in 50,000 years. Nobody involved in the transmission will be alive to see the response. This wasn't a practical attempt at communication. It was a demonstration that we could send messages, a symbolic gesture, a way of saying that we're here, we're aware of the cosmos, and we hope someone's listening. Since then, there have been other transmissions. Messages sent toward nearby stars. Signals encoded with information about Earth and humanity. Some scientists object to these transmissions, arguing that we shouldn't advertise our presence without knowing what's out there. But as mentioned earlier, we've been broadcasting radio signals for a century. If anyone nearby is listening, they already know we're here. The content of these messages is fascinating to consider. What do you tell aliens about humanity? What represents us fairly? Do you show our achievements, art and science and music? Do you acknowledge our flaws, our wars and environmental destruction? Do you send mathematical concepts, assuming they'll be universal? Or do you send more abstract ideas, emotions, hopes, dreams? The truth is, any message short enough to transmit is hopelessly incomplete. Humanity is vast and contradictory and complex. You can't summarize us in a few gigabytes of data. Whatever we send will be a fragment, one perspective, one snapshot of who we are at a particular moment. And that's okay. A fragment is better than nothing. An incomplete introduction is better than silence. As you rest now, imagine being part of the team designing a message to aliens. What would you want them to know? What images, what sounds, what ideas would you choose? It's a thought experiment that forces you to consider what matters most about being human. And different people would answer differently, which is itself revealing. We're a species without consensus, diverse and argumentative and creative. Maybe that's worth communicating too. The practical challenges of contact are as interesting as the philosophical ones. If we receive a message, how do we decode it? How do we distinguish between a message with meaning and random noise? We'd look for patterns, structures, mathematical relationships. Prime numbers are a favorite proposal because they're universal. Any civilization doing mathematics would recognize prime numbers. A signal pulsing in prime number sequences 2, 3, 5, 7, 11, 13 would be immediately identifiable as artificial. From there, you might build more complex messages. Use binary to encode images. Use frequency modulation to encode audio. Layer information so that simple decoding reveals simple content, but deeper analysis reveals more complexity. It's like a cosmic onion, peeling back layers to find deeper meaning. But again, this assumes aliens think in ways similar to us. What if their cognition is so different that our logical structures are meaningless to them? What if they don't use prime numbers because their mathematics developed along completely different lines? Communication might require more than just decoding. It might require developing an entirely new framework for understanding, one that bridges two different kinds of minds. Let that challenge settle without anxiety. The universe doesn't guarantee that all intelligences can communicate, but the effort to try, the attempt to build bridges across cognitive gaps, that's worthwhile regardless of success. Reaching for understanding, even if we never fully achieve it, expands what we're capable of. Now let's talk about what first contact would actually mean for humanity. Not the mechanics of detection or communication, but the social, psychological, philosophical impact. The day we confirm that we're not alone would transform human civilization in ways we can barely imagine. Every religion would need to reconsider its doctrines in light of alien intelligence. Most religious texts focus on humanity's relationship with the divine without mentioning other intelligent species. How would Christianity, Islam, Hinduism, Buddhism adapt to knowing that God or gods created multiple intelligent species? Some theologies would accommodate this easily. Others would face challenges. Religious scholars would spend centuries reinterpreting sacred texts in light of the new reality. Philosophy would transform too. Questions about consciousness, purpose, meaning, all would be recontextualized. Is consciousness unique to Earth-based biology, or is it a universal property of complex systems? If aliens ask the same philosophical questions we do, does that suggest universal truths we can discover together? Or does it mean consciousness inevitably generates certain questions regardless of what conclusions it reaches? Science would enter a new golden age. Proof of extraterrestrial life would energize research in biology, chemistry, physics, astronomy, all the fields that touch on understanding life and intelligence. Funding would pour into space exploration and SETI research. International cooperation would increase because the discovery transcends national boundaries. Humanity would unite around shared questions about our place in a populated cosmos. But there would be challenges too. Some people would be frightened. Fear of the unknown, fear that aliens might be hostile, fear that contact could bring disease or conflict or subjugation. These fears wouldn't necessarily be rational, but they'd be real. Governments would need to manage public reaction carefully, providing information while preventing panic. There'd be disagreements about how to respond. Should we send a reply? What should we say? Who decides? The UN would likely take the lead in coordinating Earth's response, but individual countries might act independently. Corporations might try to profit from the discovery. Conflicts would arise over who speaks for humanity and what we should communicate. And if the aliens are more advanced than us, which seems likely if they can contact us and we can't contact them, how do we handle that psychologically? Human civilization has always assumed we're the pinnacle of development. Learning that we're not, that we're potentially primitive compared to others, could be humbling or demoralizing depending on how it's framed. As sleep deepens, let yourself imagine that moment. The announcement, the confirmation, the global realization that we're not alone. How would you feel? Excited? Frightened? Curious? Overwhelmed? There's no right answer. The emotional response would vary by person, by culture, by worldview. But one thing is certain. It would be one of the most significant moments in human history, comparable to the development of language, agriculture, or science. Some scientists think contact would be less dramatic than we imagine. We'd detect a signal, confirm it's artificial, announce the discovery. There'd be excitement and press coverage and academic conferences. But day-to-day life would continue mostly unchanged. You'd still go to work, still pay bills, still have the same relationships and responsibilities. The aliens would be real but distant, acknowledged but not present in daily life. This is probably realistic for the first few years after detection. But over time, over generations, the implications would sink in. Education would change to include comparative studies of human and alien development. Art would be influenced by knowing there are other creators in the universe. Politics would gradually shift as humanity developed a more cosmic perspective on our problems. The long-term effects might be more profound than the immediate ones. A slow transformation of human consciousness as we adapt to being one species among potentially many. A gradual development of cosmic identity, seeing ourselves not just as citizens of countries, but as members of Earth's biosphere and eventually the galactic community, even if that community only interacts via messages taking thousands of years to exchange. This brings us to a beautiful possibility. What if contact leads to something like a galactic internet? What if civilizations throughout the galaxy are already exchanging information, creating a vast network of knowledge accessible to anyone who learns to tune in? We might gain access not just to one alien civilization's knowledge, but to accumulated wisdom from dozens or hundreds or thousands of civilizations over billions of years. Imagine downloading the complete history of species that evolved and went extinct a billion years ago. Imagine access to scientific knowledge developed by minds completely unlike ours, approaching problems from angles we never considered. Imagine art, music, philosophy from perspectives we can barely imagine. It would be the greatest library ever assembled, and we'd be new members gaining access. Of course, this assumes aliens are willing to share. They might be protective of their knowledge. They might require us to contribute before we can receive. They might test us to ensure we're ready for what they have to offer. Joining a galactic community might come with responsibilities and expectations we'd need to meet. But even the possibility is thrilling. The idea that there might be a cosmic conversation already ongoing, that we just need to learn the frequency and the protocols to join in. That loneliness might not be permanent. That isolation might be a temporary condition of our development, one we're on the verge of ending. Let that hope support you as consciousness fades. We might be alone, and that's okay. But we might not be. And the possibility of contact, the chance that everything could change, that we could join something larger than ourselves, that possibility is worth holding on to. The search continues. Telescopes scan the skies. Computer algorithms sift through data looking for patterns. Scientists dedicate careers to this question. Are we alone? And every day we don't find an answer is another day of possibility, another day where contact could happen, another day where our search continues with hope. You're part of this search simply by caring about it, simply by wondering, simply by looking up at the night sky and feeling curious about what might be out there. You don't need to be a scientist. You don't need to work at SETI. You just need to keep the question alive in your awareness. That's participation. That's contribution. And maybe, during your lifetime, the answer will come. A signal detected and confirmed. A message decoded. Proof that we're not alone. It could happen tomorrow. It could happen in 50 years. Or it might not happen for centuries. But the possibility remains, and that's what makes the present moment so interesting. We're living in the era when first contact might happen. For all of human history before now, we could only wonder. Now we're actively searching with tools sophisticated enough to actually find something if it's there. This is the transition period, the time between pure speculation and potential confirmation. The time when everything could change. Sleep now in that potential. Rest in possibility. Dream of the moment when silence is finally broken by a message from the stars. Dream of understanding, connection, relationship across the void. Dream of humanity taking its place in a larger community of conscious beings. Or dream of continued solitude, of Earth as the universe's only witness, precious and unique and alone. Dream of the responsibility that comes with being the only ones, the cosmic duty to preserve consciousness because we're the only example. Either dream is valid. Either future is meaningful. Either answer to the question transforms what it means to be human. We just don't know yet which answer is correct. And in that not knowing, in that fundamental uncertainty about our place in the cosmos, there's a kind of freedom. We get to wonder. We get to search. We get to hope. The question remains open, and that openness is a gift. Rest in that gift. Sleep in that mystery. Let the vast universe hold you in its unknowing. Let the stars continue their patient vigil while you dream. Let the search continue while you rest. The cosmos is patient. It's been here for 14 billion years. It can wait a little longer for us to find the answer. And we can afford to be patient too. To search thoroughly rather than hastily. To hope without demanding immediate confirmation. To wonder without requiring certainty. That patience, that willingness to live with mystery, might be one of the most valuable things the search for aliens teaches us. Not everything needs to be known now. Some questions take generations to answer. Some mysteries unfold slowly across centuries. And that's okay. That's how the universe works. On timescales longer than individual lives, revealing its secrets slowly to those patient enough to keep looking. You've kept looking tonight, in your own way. You've contemplated the possibility of life beyond Earth. You've wondered about contact and communication and what it would mean. You've allowed yourself to hope that we're not alone while accepting that we might be. And in that contemplation, you've participated in humanity's oldest and deepest question. Thank you for wondering with me. Thank you for allowing these possibilities into your awareness. Thank you for caring enough about the cosmos to spend an hour considering our place within it. Now, truly, deeply, completely, sleep. Let the universe continue its work while you rest. Let the stars shine unobserved. Let the search continue in laboratories and observatories around the world. Let possibilities remain possibilities. Let mysteries remain mysterious. And wake tomorrow refreshed, carrying perhaps a little more wonder, a little more cosmic perspective, a little more appreciation for how strange and beautiful it is to be a conscious being in a universe full of questions. The search for alien intelligence is ultimately a search for ourselves. What are we? What matters to us? What do we hope for? How do we understand our place in the vastness? These questions don't require aliens to exist for them to be valuable. The asking itself has worth. So keep asking. Keep wondering. Keep looking up. Whether we're alone or surrounded by life, the universe remains vast and strange and worthy of attention. And you remain part of it, a conscious moment in cosmic time, brief and precious and connected to everything. Before you drift into final, complete sleep, let's hold one more thought together. One more perspective on what all of this means. Because the search for alien intelligence, ultimately, is not just about finding them. It's about understanding ourselves in cosmic context. It's about recognizing what makes consciousness valuable, rare, or common, precious either way. Think about what you are for a moment. You're a collection of atoms that were forged in the cores of dying stars billions of years ago. Carbon, oxygen, nitrogen, iron, all the elements that make up your body were created by nuclear fusion in stellar furnaces and scattered across space when those stars exploded. You are literally made of stardust. This isn't poetry. This is physics. You are the universe rearranged into a form that can know itself. Those atoms somehow organized themselves into molecules. The molecules somehow organized into cells. The cells somehow organized into tissues, organs, systems. And somehow, impossibly, wonderfully, that organization gave rise to consciousness. To you, to the awareness reading these words, feeling these thoughts, existing as a subjective experience. We don't fully understand how that happens. We don't know how matter becomes mind, how chemistry becomes consciousness, how atoms become awareness. It's one of the great mysteries of existence. And whether it's common or rare elsewhere in the universe, it happened here. It happened in you. And now you use that consciousness to contemplate the possibility of other consciousnesses elsewhere in the cosmos. You use your awareness to wonder about other awareness. You use your intelligence to search for other intelligence. It's a beautiful recursion. The universe thinking about itself through you, wondering if it's thinking about itself through others elsewhere. Let that settle deeply as sleep approaches. You are not separate from the cosmos. You are an expression of it. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, all were made in stars. You are not in the universe. You are the universe, locally organized in a way that permits experience, understanding, wonder. And if aliens exist, they're made of the same stuff. Different arrangements perhaps, different chemistry maybe, but the same underlying elements created by the same cosmic processes. We'd share a common origin even if we evolved separately. The supernova that created the elements in your body also created elements in other star systems. We'd be cousins in the deepest sense, children of the same cosmic processes. This means that finding alien life wouldn't just be discovering something external and foreign. It would be discovering another expression of the universe's creative potential, another way that matter can organize itself into meaning, another variation on the fundamental theme of existence becoming aware of itself. And if we're alone, if life is unique to Earth, then every living thing becomes unspeakably precious. You, every person you know, every animal, every plant, every microbe, all of it the only example of the universe achieving self-awareness. The only instance of matter organizing into mind. The only witnesses to the cosmic story. Either way, you matter. Either as one example among many, or as the only example. Either as part of cosmic community, or as the universe's sole witness. The question of whether we're alone changes the context, but not the fundamental value of your existence. As you drift now, feeling sleep pulling you deeper, let yourself appreciate that value without needing comparison. You exist. You're aware. You can experience beauty, wonder, curiosity, love. That's extraordinary regardless of how common or rare such capacity is elsewhere. The aliens, if they exist, would recognize this. Any intelligence sophisticated enough to contemplate the universe would understand that consciousness, wherever it arises, is precious. They might be so different from us that communication is impossible, but they'd understand, in their own way, the miracle of awareness. They'd know what it means to look at the cosmos and feel wonder. And maybe that's the universal language. Not mathematics, not symbols, but the shared experience of being aware in a universe full of mystery. The recognition that consciousness, however it manifests, is something rare and beautiful, something worth preserving, something worth celebrating. If first contact happens, maybe that's what we'd communicate first. Not our technology or our science or our achievements, but simply, we are here, we are aware, we wonder about the universe just as you do. And maybe that would be enough. The recognition of kindred spirits across the void, different in form but similar in essence. All of us temporary patterns of organization in the cosmic flow, all of us brief witnesses to something vast. Let that possible connection support you as consciousness fades completely. You're connected already to everything through your constituent atoms. You're connected to possible alien intelligence through shared participation in the universe. You're connected to past and future through the ongoing story of matter becoming aware. Those connections don't require belief. They're physical facts. You are made of star stuff. You are the universe knowing itself. Whether alone or among many, you participate in something profound simply by existing, by being aware, by wondering about what else might be wondering. Sleep now with that knowledge. Rest in your cosmic identity. Dream of yourself as what you really are, a temporary organization of ancient atoms given the gift of awareness, using that gift to contemplate whether the same gift has been given elsewhere. The answer will come someday, or it won't. The search will succeed, or it will continue indefinitely. First contact will happen in your lifetime, or it won't happen for 1,000 years. All of these are possible. All of these are okay. What matters is that we keep wondering. Keep searching. Keep hoping. Keep looking at the stars with curiosity and openness. Keep asking the question that makes us human. Are we alone? Because in asking, we affirm our own consciousness. In searching, we demonstrate our capacity for curiosity. In hoping for contact, we reveal our desire for connection. These qualities, asking and searching and hoping, these make us who we are regardless of what we find. The aliens, if they exist, are probably asking the same questions. Are we alone? Is anyone out there? Will we ever make contact? They might be searching for us just as we search for them. They might be hoping for connection just as we hope for connection. Two lonely intelligences reaching across the void, hoping the other exists, hoping for the moment when loneliness ends. Or maybe we are alone, and the universe is waiting for us to spread outward, to become the builders of civilization among the stars, to be the consciousness that fills the cosmic emptiness with meaning and purpose and wonder. Maybe we're not searching for aliens. Maybe we're becoming the aliens that future civilizations will search for. Either role is meaningful. Either possibility is beautiful. Searcher or searched for, finder or found, member of galactic community or pioneer of cosmic settlement. All of these are worthy ways to exist in the universe. And for now, in this moment, as sleep takes you completely, you don't need to be any of those things. You just need to be you. Aware, wondering, resting, letting the great questions settle into dream, letting the cosmos continue its patient unfolding while you sleep. The search continues tomorrow. The questions remain. The possibilities endure. And you'll wake refreshed to participate again in the ongoing human story, the search for understanding, the reaching toward connection, the wondering about our place among the stars. For now, just sleep. Deeply, peacefully, completely. The universe holds you. The atoms that compose you have been here since the beginning. They'll be here long after you. And for this brief moment, they're organized in a way that permits your experience, your awareness, your wonder. That's enough. That's always been enough. That's everything. Good night.